Okay. Hi, everyone. You are welcome to session B. And now our presenter is Merve Gördesel Yıldız, and who is a PhD student at Gazi University, Department of Chemical Engineering, and also lecturer in the same department. She is going to present us entitled Parametric Study in Electrochemical Reforming of Glycerol for Hydrogen Production. Dear Yıldız, are you here?
Yes, I'm here.
Okay, you can start your presentation,
Okay,
please.
I'm here. I'm sharing presentation video. Can you see it clearly?
Yes.
Okay, I'm starting.
It's very well. Okay.
Hey everyone, I would like to quickly introduce myself. I'm Merve Gördesel Yıldız from Gazi University Chemical Engineering Department. I will present findings on parametric study in electrochemical reforming of glycerol for hydrogen production. To start with, I will talk about hydrogen production and glycerol electrochemical reforming. After that, I will explain experimental setup and procedure. And finally, I will present my results. Hydrogen stands out as a clean and ideal fuel for all energy systems, with its features such as high energy density and zero emission. Conventional hydrogen production is predominantly of fossil fuels, and producing hydrogen from clean and renewable resource is important for sustainable of hydrogen. And various methods are available for hydrogen production. We focus in this presentation is electrolysis. Electrolysis is the best option for producing hydrogen very quickly and conveniently. Rather than electrolysis of water, alcohol electrochemical reforming can be used to produce clean hydrogen, resulting in improvement the overall system performance. Use the system and alcohol, especially glycerol, as the anode in electrochemical cell is energetically favorable than oxidation of water for hydrogen production. Since alcohols are oxidized at a lower potential than water with a lower electrical consumption. Glycerol is formed as a byproduct of 10% during the transesterification reaction that plays in production of biodiesel. The rapid development of the biodiesel industry during the last decade has resulted in significant oversupply of glycerol on the world market. During the electrochemical reforming of glycerol, the following reaction occurs an anode and cathode. Glycerol is highly functionalized molecule with 3 hydroxyl groups, which makes it promising candidate for conversion into the more valuable products such as hydrogen. In the electrochemical reforming method, an electrical potential is applied between 2 electrodes separated by membrane, and the electrooxidation of glycerol occurs at the anode. The protons formed in anode compartment pass through the selective membrane to the cathode compartment. Hydrogen is formed by combining with the electrode from the outer circuit. In experimental setup and procedure, the electrochemical production of hydrogen from glycerol in acidic aqueous media was investigated in 2-compartment membrane electrolysis cells. The overall this system's volume is 1,500 milliliters. Zinc electrode pair was used in the plate formed the anode and cathode. The distance between the electrodes was 12 centimeters. The system has been used different conditions with and without membrane. In the membrane system, Nafion 117 and the Nafion XL membrane were used. In the membrane system, experiments carried out the presence of acidic glycerol solution at the anode and dilute sulfuric acid solution at the cathode. In previous study, the most suitable concentration has been determined as 0.4 molyglycerol, and this value has been used in these experiments. Here you can see our experimental system. In this system, current density values obtained against the applied potential are recorded and polarization curve are plotted. Current density values are directly related to the rate of hydrogen production. In this study, the effect of membrane pretreatment procedure, temperature on the cell performance was investigated. In addition, system response was examined by long-term performance tests and gas product was analyzed. If I talk about results, the system must operate with or without membrane. Membrane provides the opportunity to work with different solution compartments in the anode and the cathode. A membrane system was used in the proceeding stage of the study. In the membrane system, two different Nafion membranes are used. Some of properties of these membranes are given in table. There is approximately 6.6 time difference between the thickness of Nafion XL and Nafion 117 membrane. As the thickness of membrane decrease, the resistance and ohmic loss in the system decrease, while the ion permeability increase. As the thickness increase, the durability increase. And according to this information, both membranes have a different advantage. Compared to the results obtained from the with and without membrane at 1 voltage potential, using membrane in system increased performance approximately 28%. When Nafion XL and Nafion 117 are compared, the current density values for both cases are close to each other. However, when Nafion XL membrane used, current density values for all potential values are slightly higher. Especially at high temperature value due to the limitation of the present system. It has become difficult to ensure the sealing of the system by using thick membrane. That's why Nafion XL membrane was preferred in this experiment. In the experiment, different temperature values were studied in order to determine the effect of temperature on the system. And increase the temperature positively affects the electrochemical reforming of glycerol. Current density values obtained at 20 Celsius degree and 19 Celsius degree are compared. And the current density value have increased approximately 1.7 times with the increase in temperature. The membrane is used experimental system were activated with a different pretreatment procedure. Hence, the amount of water molecules bound sulfuric acid group in the membrane structure was increased. The water molecules in Nafion membrane create weak bonds with protons, allowing the hydrogen ion to move from anode compartment to the cathode compartment. For this reason, ion exchange over the membrane occurred more efficiently with pretreatment. In this study, pretreatment performed with different solutions for different duration were applied to the membrane. In the first procedure, membrane pretreated with peroxide, hydrogen peroxide, deionized water, and sulfuric acid, respectively. In second procedure, hydrogen peroxide wasn't used, and pretreatment time is longer. And third procedure considered as the sum of first and second procedures. As you can see, the most effective pretreatment procedure is 3. The procedure 3 is pretreatment with higher membrane solution contact time compared to other procedures. At the 1 voltage potential, the membrane pretreats according to the procedure 3 about 40% more efficient than non-pretreatment membrane. To see the long-term response of the system performance test has been done, and during the experiments, especially after 5 hours, the zinc anode and cathode electrodes were oxidized and dissociated in the solution, and electrodes active surface area are decreased. According to this result, the current density values also decrease. In here, gas products at the anode and cathode under different operating conditions analyzed with gas chromatography. And pure hydrogen was detected at the cathode, and carbon monoxide and carbon dioxide mixture was detected at the anode in all experiments using the membrane. According to the cathode peak area, the highest hydrogen formation was obtained when the pretreatment membrane as procedure 2 was used. In briefly, this study indicates that glycerol electrochemical reforming can be operated high current density and at a much lower operating condition, operating voltage, compared to water electrolyzer. Optimum condition and maximum hydrogen production under the operating condition examined in current system is obtained at 90 Celsius degree with the zinc-zinc electrode pair in presence 0.4 molar glycerol and 0.04 molar sulfuric acid at the anode and 0.04 molar sulfuric acid at the cathode side, with Nafion XL pretrate according to procedure 3. According to the gas analysis, it's necessary to use membrane for hydrogen, pure hydrogen production. In this case, no purification process is required. The contribution of the pretreatment applied membrane for both the current density value and the hydrogen production produced was recorded. The electrochemical reforming of glycerol is promising option for the future condensate hydrogen production with innovative method for alternative source in terms of selectivity, efficiency, and operating condition. We continue to work on glycerol electrochemical reforming. We are working on, for example, MEA integration into the systems. Thank you for listening and being here.
Thank you very much for your presentation. And do we have any question? Any question? Okay. I have a question for you. Do you calculate the efficiency of the system according to procedure 3?
Not yet, but measure hydrogen production, hydrogen formation rate, and we calculate the hydrogen production 0.08 milliliter per minute. But XRG analysis we're going to.
Okay, because the electrochemical reforming of glycerol for hydrogen production. Very interesting subject. Okay, good luck, Mary.
Thank you, Professor.
You can leave now. And our next presenter is the Özgü Yörük Yıldız, who is the PhD student. Who is the PhD student at Gazi University Department of Chemical Engineering. And she also a lecturer in the same department. She is going to present her study entitled Investigation of Different Parameters Affecting Current Density in Hydrogen Production by Coal Electrolysis. Okay. Dear Özgü, could you hear me?
Yes, I'm here.
Okay, you're welcome. And you can share, or someone will share your presentation.
Okay, I'm sharing. Can you see?
Yes, yes.
Okay, welcome to our presentation. Today, I'm going to talking about our work entitled Investigation of Different Parameters Affecting Current Density in Hydrogen Production by Coal Electrolysis. And to start with, I will talk about hydrogen production, electrolysis, and coal electrolysis. And after that, I will explain experimental setup and parameters and their results. And finally, I will present conclusions. Hydrogen, which is storable, renewable, clean, economical, and sustainable, is seen as the most important energy carrier and therefore the fuel of the future. Strong interest in the use of hydrogen has led to search of various methods to produce hydrogen in a safe and convenient way. You can see on the screen a schematic illustration of hydrogen production methods. Hydrogen is not natural energy source, so energy is required for its production. And when hydrogen production methods are considered, electrolysis is a possible method in order to obtain pure hydrogen among alternative methods. As can be seen from the screen, according to the 2015 reports of the International Energy Agency, natural gas is the most common source used in hydrogen production today. Natural gas is followed by oil and coal, respectively. It's foreseen that the share of electrolysis method, which is less used today, in the production of hydrogen until 2050, 22%. In this respect, the importance of electrolysis in hydrogen production method is increasing. However, high energy consumption is the biggest disadvantage of the method. The high cost resulting from the high energy need in the electrolysis of water can be reduced by using different sources in electrolysis. Thus, more economical hydrogen production is possible. Hydrocarbon-assisted electrolysis has the potential to offer less energy-intensive and relatively clean method of using the chemical energy in various sources of carbon, such as long-range coals, alcohol, methane, biomass, where pure carbon dioxide produced can be easily sequestered without need for separation. In our study, we preferred coal from source that could be used for hydrogen production by electrolysis because among the resources from which hydrogen can be produced, coal is the suitable options for electrolysis due to its abundant reserves and low cost. So why did we choose coal? And the answer to this question is shown in table 1. And table 1 shows the theoretical cell voltage values of the coal and water. Water is the most reasonable source for large-scale hydrogen production. However, the electrical energy used in this method is so high, so this increases the unit price of hydrogen. And while the standard potential of water electrooxidation is 1.23 voltage, this value is 0.21 voltage in coal electrolysis. The use of coal as the electrolysis source significantly reduces electricity consumption. Using coal as source in the electrolysis process is a preferable method in terms of thermodynamics and because of less energy requirement compared to hydrogen production by electrolysis of water. When the electrolysis of water and coal electrolyzers are compared for the production of equal amount of hydrogen, approximately 60% of required energy is provided from the carbon from the coal, and thus more economical hydrogen production is possible using less electrical energy. And electrolysis of coal, reactions that occurs in hydrogen production from coal by electrolysis method are as shown on screen. In electrolysis of coal, coal water slurry were supplied to the anode of the cell and DC power was applied. And the electrons produced at the anode move to the cathode through the external circuit and combines with the proton to produce hydrogen at the cathode. As seen from overall reaction, 2 mole hydrogen is formed from 1 mole of carbon. In addition, pure hydrogen can be supplied instantly for energy application without the need for purification process. If I talk about the structure of coal, there are wide variety of functional groups in the structure of coal, which is an organic substance. And in coal electrolysis, it is known that not only carbon, but also various functional groups such as OH, COOH, and COC in the structure of the coal have an effect. For this reason, predicted that the increase in the functional group content in the coal structure will have increasing effect on the current density in hydrogen production by electrolysis. FTAI analyzed of 4 different coals at different geological ages were performed. If I talk about the experimental setup, first of all, FTAI analysis of 4 different coal samples was performed to determine the functional group content, and the coal sample with the highest functional group content was selected for electrolysis experiment. Then all parametric experiments were carried out in a 0.25 liter simple electrolysis cell, which you can see on the screen, and using 1 molar sulfuric acid in an acidic environment with the potentiostatic method. As displayed in figure 3, there are peaks showing the mineral region at 400 to 800 wavelengths in all samples, and the sample with the highest mineral group content in Chan low calorific value, when the peak intensities represent the carbon-carbon double bond in the region are compared, the Kütahya and Tekirdağ samples are more charred. In addition, if the samples are evaluated in terms of functional group content, especially the peaks in the 1000 to 1100 and 1400 regions should be examined. It can be said that the best sample in terms of carboxylic acid and alcohol phenol functional group content is Chan low calorific value. As a result, the Chan low calorific value sample, which has more dense peaks than the other samples in the density of mineral presence and regions belonging to carboxylic acid, alcohol, phenol, and ether ester groups, was selected to be used parametric experiments. If I talk about experimental parameters, in all experiments, current density was measured against the applied cell voltage and the effect of operating temperature, iron ions, electrode materials, coal concentration, operating temperature, and distance between electrodes have been investigated. Experiments were carried out under acidic condition, and current density values are directly related to rate of hydrogen production. As for the results part, firstly, the effect of iron ion on current density was investigated. In the light of the information obtained from the literature, iron sulfate solution was added to coal water slurry in order to determine the effect of using iron ion in coal electrolyzed on current density. The change of current density values obtained at a constant temperature of 80 degrees Celsius is shown in figure 4. Based on 1 voltage, constant voltage at 80 degrees Celsius, it's seen that the current density increases by 30% with the addition of iron ion. It was observed that the results obtained were consistent with the literature, and the use of iron ions in the cave process has a catalytic effect on the current density. In this section, electrode material effect is examined. Since the effect of iron ion addition is known, and the experiments were carried out by adding iron sulfate. As you can see, figure 5, highest current density values were observed in zinc-zinc electrode pair. It showed that high current density can be achieved with lower price electrodes instead of using expensive electrodes, and thus zinc electrode has been found suitable for coal electrolytes and it's chosen for further studies. In this section, cold concentration and temperature effect is examined. It was determined that there was an optimal coal concentration rather than a linear increase between the selected coal concentration. And as can be seen in figure 6, the highest current density values of 0.03 gram per milliliter coal concentration was seen at 50 Celsius. And these results show that the cave process can be performed at low temperatures. This result is important in terms of energy saving. In addition, it has been observed that the amount of coal used can be reduced. And final experimental section, distance between electrodes effect in examined. As seen figure 7, as the electrodes get closer to each other and the current density values increase, positioning the electrodes close to each other has an effect on keeping the solution resistance to a minimum, resulting in higher current density and associated higher hydrogen formation. And briefly, electrolysis process was carried out effectively with a type of coal with high functional group content and low calorific value, and with the addition of iron ion to the coal water slurry an improvement in current density at the same potential was observed. Electrolysis of coal was achieved by applying lower cell voltage compared to water, and the cost of electrode material was reduced by using more affordable electrodes such as zinc, and high current density could be obtained by using less amount of coal, and higher current density was obtained as the resistance inside the cell were minimized with the closer electrode distance. And thank you for listening and being here.
Okay, thank you very much, Pınar. And this was a high topic in hydrogen energy now, and this is the very good parametric study. And do we have any question, please? First, I will decide to ask what kind of coal do you think to use, but then I understand you explained it very well. Again, thank you very much. Good luck your work.
Thank you.
Okay. And now our next presenter is Salah Ahmed Ibrahim from Chadian, was graduated from Eskişehir Technical University, Department of Chemical Engineering. Now he is a master's student at Gazi University, Department of Chemical Engineering. Today he is gonna present her study entitled Coke minimization through nickel-based mesoporous catalyst in steam reforming of acetic acid for hydrogen production, effect of temperature, and feed molar ratio. Okay. Okay, Salah, are you here?
Yes, I'm here.
Okay, you're welcome. Okay, you share your presentation. Okay,
Yes, thank you
you
so
can
much
go
for
on.
the presentation. In this presentation, I'm going to present our study titled Coke Minimization through Nickel-based Mesoporious Catalyst in Steam Reforming of Acetic Acid for Hydrogen Production, Effect of Temperature and Feed Molar Ratio. I will start with a brief introduction about hydrogen, followed by thermodynamic analysis of the reforming reaction, catalyst synthesis and characterization, activity test result, and a brief conclusion. If we observe what happened during the last century, population, economic wealth, and energy consumption grow almost without any interruption. Global population was 1.6 billion in 1900, and we are more than 7 billion human beings today. Wealth estimated by gross domestic and real value has been multiplied by a factor of 40 over the same period. Energy consumption has been both a support and a consequence for this growth, rising slightly from less than 1 billion ton of oil equivalent at the beginning of the century to more than 13 billion ton today. However, there is not one single type of energy, but several. Today, we hear a lot about energy transition, but the global energy mix has been changing since the Industrial Revolution. As a matter of fact, we moved from a traditional mix base almost entirely on wood at the beginning of the 19th century to a much more diversified energy supply today. Indeed, our current primary energy consumption rely on fossil fuel for more than 80%. This large dependence on fossil fuel has given rise to serious environmental issues such as greenhouse gas emission. To replace the dirty fossil fuel by a new form of energy and to cut down the accumulation of carbon dioxide into the atmosphere, developing countries have been concentrated on using sustainable sources such as biomass-derived biofuel. One of the most noteworthy clean energy sources which has fascinated researcher attention is hydrogen. Hydrogen unique properties such as high energy density, the non-polluting nature, versatile application, the suitability for continuous use make it the appropriate alternative energy carrier to decarbonize the energy sector. The objective of this study is to develop innovative nickel-containing mesoporious gamma alumina supported catalyst with large surface area, tunable pore sizes, highly uniform channel, and mild surface acidity that will be used to produce alternative fuel hydrogen from biomass-derived acetic acid. Consequently, steam reforming is regarded as a model reaction for hydrogen production from biooil. The main reforming reaction is regarded as a combination of acetic acid cracking reaction and water gas shift reaction. However, depending on the reaction condition and catalyst properties, some secondary reaction such as decarboxylation reaction, methanization, and carbon formation reaction may take place. To define the optimum reaction condition at which acetic acid is completely converted into highly selective hydrogen-rich gas, the thermodynamic feasibility of the reforming reaction is entirely examined. The thermodynamic equilibrium composition of the reforming reaction of acetic acid were performed using GASEC software through the minimization of the total Gibbs free energy. Acetic acid is used as a model compound to simulate the reforming reaction. Besides, uh, this software requires not only the specification of the desired and undesired product, the feed molar ratio, but also the inlet temperature, the reaction temperature, and the reaction pressure. As can be seen from figure 3 and 4, hydrogen and carbon dioxide selectivity at different input feed molar ratio are given as a function of temperature. In figure 3 and 4, uh, hydrogen and carbon dioxide selectivity increases significantly with increasing temperature and feedstock molar ratio. At lower temperature, insufficient hydrogen selectivity were obtained. But when the temperature starts to increase, hydrogen selectivity increases and reach its maximum value of 95% at 550 centigrade and a feed molar ratio of 1/10. Additionally, carbon monoxide and methane selectivity were given as a function of temperature in figure 5 and 6 respectively. As can be seen, at lower temperature, up to 450 centigrade, negligible carbon monoxide selectivity values were obtained. But when the temperature start to increase, high carbon monoxide selectivity were obtained, and this can be explained by the nature of the reaction, which is responsible for carbon monoxide production, which is the water gas shift reaction. However, methane selectivity values were very high at low temperature, but they start to decrease significantly when the temperature increases and and the feed molar ratio increases. This is also can be explained by the nature of the methanization reaction, which is responsible for methane production. The equilibrium product distribution of gaseous product obtained at a feed molar ratio of 1/2.5 as a function of temperature is given in figure 7. As can be seen, up to 250 centigrade, acetic acid broke down completely into equimolar concentration of carbon dioxide and methane respectively. When the temperature starts to increase, hydrogen selectivity increases while methane selectivity decreases. At 700 centigrade, hydrogen proportion reaches its maximum value of 93.5, while methane proportion decreases to 0. As the temperature continues to increase from 700 to 1000 centigrade, hydrogen molar fraction decreases from 72 to 65%. As a result of the thermodynamic analysis, a temperature of 750 centigrade and a feed molar ratio of 1/2.5 were chosen as operating parameter of the reforming reaction. Mesoporious gamma alumina supported catalyst was prepared following a hydrothermal preparation method. For this purpose, aluminum 3 isopropylate, 3-block copolymer, nitric acid, and absolute ethanol were used as aluminum source, soft template, acid source, and solvent respectively. The hydrothermal preparation method consists of 4 main steps, which are the preparation of the aqueous solution, the hydrolysis, drying, and calcination. The monometallic and bimetallic catalysts were prepared by incorporation of nickel and or magnesium metal following a wet impregnation method. The prepared catalytic material were calcinated at 800 centigrade under the flow of dry air for 6 hours and reduced under the flow of hydrogen at 750 centigrade for 1 hour. All the prepared catalysts listed in this table were characterized by XRD, nitrogen absorption desorption, SEM, drift, thermogravimetric analysis, and differential thermal analysis, and tested for hydrogen production. XRD analysis were used to define the crystal structure of the prepared catalyst. As can be seen from figure 10, the strong peak observed at 0.74 supported the formation of highly ordered mesoporous structure with amorphous wall. Besides, in figure 11, in the wide-angle X-ray diffraction pattern, it was determined that the support material preserved its mesoporosity, and nickel particles were added without deteriorating the pore structure of the material, suggesting a successful incorporation of the metallic nickel. Additionally, to define the surface area, the pore size and pore volume of the prepared catalyst, nitrogen absorption desorption analysis were used. According to the UPAC classification, Type 4 is the thermal behavior, and H1 hysteresis loop were obtained. Type 4 is the thermal behavior, indicate the well-defined narrow pore, while H1 hysteresis loop confirm the mesoporous nature of the prepared catalyst. Additionally, SEM analysis were used as well to define the morphology of the prepared catalyst. According to the obtained SEM images, it was observed that the metal were homogeneously distributed into the surface of the support material. Some images of nickel and magnesium containing metal reveal that the metal species were more densely distributed in the structure of bimetallic catalysts than the pure material and monometallic catalyst. Drift analysis were used to define the Lewis acid, Bronsted acid, and Lewis-Bronsted acid site. As can be seen, the clear visible band at 1,446 and 1,597 correspond to the strong Lewis acid region. After the addition of nickel particle into the structure of the pure material and monometallic catalyst, the intensity of the intensity corresponding to the Lewis acid were increased. The peak observed at 1,490 per centimeter was designed to the Lewis Bronsted side. The acid strength of the bimetallic catalyst was decreased after the addition of the basic metal magnesium. The catalytic steam reforming of acetic acid was conducted in a conventionally heated reactor system at a temperature of 750 centigrade, a feed molar ratio of 1/2.5, and a total gas flow rate of 82.5 milliliter per minute. First of all, an initial experiment was carried out over the pure catalyst support. As a result, poor catalytic activity, low hydrogen selectivity, and acetic acid conversion of 93 were obtained. As expected, nickel introduction enhances the reforming reaction by increasing hydrogen selectivity from 7.5 to 82%, improving the thermal stability of the prepared catalyst and raising acetic acid conversion from 93 to 100%. In addition, in the initial experiment, a large amount of methane and carbon dioxide were obtained. However, nickel incorporation reduces the proportion of undesired products such as methane and carbon dioxide, but increases the amount of carbon monoxide. Therefore, nickel impregnation reduces the formation of side reaction and favors the reforming reaction by breaking carbon-carbon, carbon-hydrogen, and carbon-oxygen bond. Then the influence of temperature on the selectivity and acetic acid conversion over the catalyst showing the highest thermal stability was investigated. Steam
Dear
reforming of
Sela,
acetic acid.
sorry, I am sorry. Last 2 minutes.
Okay.
Could you finish your presentation, please?
Okay. A steam reforming of acetic acid is an endothermic reaction. So at higher temperature, the reforming reaction is favored. As can be seen in this graph, at lower temperature, acetic acid conversion was very low and considerable amount of methane and carbon dioxide were obtained. But when increasing the reaction temperature from 550 to 750, the acetic acid conversion were increases and methane and carbon monoxide concentration in the product distribution was reduced. Additionally, the effect of feed molar ratio on the selectivity and acetic acid conversion were investigated as well. When we increase the amount of water in the feedstock, hydrogen proportion increases in the production distribution and favoring the steam reforming reaction. As a result, the variation of water proportion from 2.5 to 5 increases hydrogen selectivity from 82 to 85%. And at the feed molar of, ratio of 1/10, the maximum attainable hydrogen selectivity of 91% was obtained. The thermogravimetric and differential thermal analysis were used to define the type and the amount of carbon formed on the spent catalyst. The highest deposition of 37.15% was obtained in the monometallic catalyst due to its high surface acidity. The addition of magnesium into the monometallic catalyst lowered the acidity and strained the chemical absorption of carbon dioxide on the catalyst surface. As can be seen,
Please, Sarah, please finish it because the other
I
presenter
have
is
unfinished.
waiting. Okay, thank you
Yeah.
very much. I'm sorry.
Okay, so I'm gonna.
Okay, conclusion.
So to conclude, we have successfully prepared nickel containing catalyst, and also from the characterization result, we obtained a large site, Lewis acid site in the surface of the catalyst, high catalytic activity, and high selectivity also were obtained. So if you have any question, I can.
Okay, thank you very much. Thank you very much for your very detailed presentation. I have several questions, but maybe we can talk to later. And thank you very much and good luck on your study.
Thank you.
Okay. Now, the next presenter is Özge Coşkuner, who is a master student at Yıldız Technical University in Chemical Engineering Department. She will present her study entitled Investigation on Cobalt-Doped Activated Carbon Catalyst to determine the hydrolysis characteristic of BN compounds. And are you here?
Yes, I'm here. I can share my screen.
Okay, thank you. You can share.
Can you see?
Not yet.
Now?
Okay, it's very clear.
Okay, good.
Greetings to all of you. It's a pleasure to present our research today here. My name is Özge Coşkuner. I'm a master's student in Chemical Engineering Department at Yıldız Technical University. I'm working in a research team led by Professor Dr. Aysel Kantürk-Figen. Today I'm going to present the topic investigation on cobalt-doped activated carbon catalyst to determine the hydrolysis characteristics of BN compounds. The research has been done together with the Professor Dr. Aysel Kantürk-Figen. I'll continue with the outline. Basically, my talk will be divided in 6 parts. First, I'm going to start with the scope, and I will give you a short summary about the investigation. Then we're going to have a short look on the literature part. In the third part, I'm going to present the experimental section. Later, I'm going to share with you the results and discussion. Finally, I'll go on to talk about the conclusion and future remarks. After my talk, there will be a time for discussion and any questions. And on the scope part, our experimental part started with the synthesis of the COAC-coded catalyst. Then we tested the catalytic activity of the catalyst over BN compounds via hydrolysis methods. And also we investigated the reusability of the catalyst with the same dehydrogenation method for totally 5 times. Finally, we studied the kinetic research of the reaction. On the literature part, I'm going to start with the solid-state hydrogen storage. The most effective and safe hydrogen storage is in the solid media, such as in BN compounds. BN compounds has several advantages to be in a solid-state hydrogen storage. Because they have a higher hydrogen carrying capacity and they hydrolyze easily. In our investigation focused on more ammonia boron, methylamine boron, and ethane 1,2-diamine boron. And first I'm going to talk about more the ammonia boron because the studies focused on more the hydrogenation process of ammonia boron. And there are some advantages of the ammonia boron that I'm gonna talk about it. It's stable at the room temperature, also in the water. It has a high hydrogen density, non-toxic, it has a high reactivity, and dehydrogenating at low temperatures. Besides the disadvantages, besides the advantages, there is also some disadvantages. For example, the borazine and ammonia release as a byproduct after ammonia boron dehydrogenation, and these byproducts are actually harmful for the fuel cell membrane. For this reason, researchers have turned to the other ammonia boron derivatives such as MEAB and the ADAB. And the previous investigations show that the MEAB and ADAB are the BN compounds which meet the DOS criteria, such as ammonium boron with the layer hydrogen storage capacities. It's also known that they do not produce any toxic byproducts during their dehydrogenation. So that's why we focused on the dehydrogenation comparison between these alternative hydrogen storage mediums. Now I would love to talk about the hydrogen production from the BN compounds. There are several ways to produce the hydrogen from the materials as hydrolysis, thermolysis, and hydrothermolysis. But today we're going to talk about the hydrolysis, which is one of the most preferred methods. And because it's in the liquid phase reaction, and that makes the easy to interaction between the molecules. And also we can see the advantages of the methods, such as the reaction can start at low ambient temperatures, be accelerated with the various catalysts, and can be controlled. And on the other part, I would love to explain the reason that why we decided to synthesize the COAC catalyst. First, I'm going to mention about the non-noble catalyst cobalt. So many studies show us that the non-noble catalyst cobalt is one of the most preferred because it has a high catalytic effects, being active at low ambient temperatures, and their low costs. It's the more significant points. So for more effective to use the cobalt, the studies show us that the non-noble catalyst cobalt nanoparticles can be used as an catalyzed by low nanosupport materials, such as an activated carbon. One of the low-cost supported material is activated carbon, and it also has a specific features as it increases the catalytic activity of catalysts, and it has a high surface area, chemical inertness, high physisorption capacity, and also the metals can grow in the structure easily. That makes this makes the activated carbon more preferable one. And also we prepared the nanocatalyst with the materials. The reason that we prepared this nanocatalyst with the higher surface area. Now I'm going to mention about the experimental section. I want to start with the materials. We purchased ammonium boron and metal MEAB and the ADAB synthesized in the laboratory. As a catalyst, we used the cobalt chloride. It also purchased, and activated carbon as a support material. It's also purchased. And I'm gonna talk about the preparation of our catalysts. Theoretically, we doped cobalt 12% per weight, and the ore is given that way. Pellet type of activated carbon was ground and sieved to smaller or equal to 50 micrometer particle size. And then we prepared the 0.2 molar cobalt chloride solution, and we add this grounded and sieved activated carbon in it and mix it. And impregnation method applied after that at 60 degrees Celsius and under vacuum. We dried this mixture at 130 degrees Celsius overnight. Then we applied the in-situ reduction method with the sodium borohydride in an ice bath. After that, we washed our mixture with the distilled water. Then we dried and we gained our catalyst. After finishing the synthesis of the catalyst, we applied some characterization methods such as an ICP-MS, BET, and TEM. And now I would love to mention about the hydrolysis and the reusability parts. The hydrolysis reactions were performed in the batch type reactor with the temperature control units in a water bath as given on the left side. 0.2 molar aqueous solution of the BN compounds reached with the 0.1 gram catalyzed at 200 RPM and a temperature range between 20 and 80 degrees Celsius in a closed system. The reusability of the catalyst was performed under the same experimental conditions, but only in 60 degrees Celsius. During the reusability experiments, when the first hydrogen release was completed, the catalyst was kept in the reaction solution and 0.001 mole BN compound was added to the medium. And now I would love to mention about the result and discussion. We're going to talk about the characterization of catalyst, hydrolysis of BN compounds, and the reusability of the catalyst. First, I will present the characterization part. ICP-MS result show us that we match our we actually meet our theoretical goal, and we doped cobalt on the activated carbon 11.84% weight. And the BET results show us that we have the our catalyzed surface area and total pore volume were 494 square meter divided gram. And our TEM results show us the particle size and the morphology of the catalysts. And the particle size was observed averagely more or less 200 nanometers, and they are dispersed on the support material well. And on the hydrolysis of BN compounds, as we can see from the graphs, the increase in the medium temperature have a positive impact on the dehydrogenation. And we can see on the graph that our catalyst is ultimate effective on the ammonium boron, and then MEAB and the EDAB follow the respectively. And the reusability of the catalyzed, if we check the graphs, and we can see that according to hydrogen generation rates of the catalyst end of the fifth run, our catalyst preserved its catalytic activity still. And on that graphic, we can also see the hydrogen generation rates of the ammonium boron. Again, this shows the higher result than the other BN compounds because related to its higher reduction activity. As in conclusion, our study was focused on the evaluation of the low-cost effective nanocatalyzed for the composition of the aqueous different BN solutions and usability of the alternative BN compounds instead of AB. That was our aim. And we synthesized our catalyst with the vacuum impregnation and in-situ reduction method. And the direct proposition was found between temperature and PGRs was expected. Ammonium boron's dehydrogenation is fast as related to its high reduction activity, and the reusability trial shows after fifth run, catalyst has same catalytic activity on average. For future remarks, we keep going on the investigation and work on the examination of the regeneration parameters, designing of the composition, and enhancing the activity by using acidic or metallic parameters. And thank you so much for listening to me.
Thank you very much, Özge. This is a very nice presentation. And do we have any question you can send to me from the chat section, please? Okay, thank you very much, Özge, and good luck in the future studies.
Okay.
Bye. Okay, now next presenter is Abdullah Tokul from Amasya University, and he will talk about renewable energy applications on Yedikır Dam. Are you here?
Hello, my
Okay.
respected teacher.
Okay, you can share your presentation.
Can you hear me?
Yes, I can.
Okay. I want to share my video presentation.
Okay, you can use the green button. Okay.
Is it visible?
Yes, it's clear. Yeah, you can go on. I am sorry, Abdullah. We can't hear you.
Uh,
Now it's okay? Okay, they open it. Try again, please. Okay, something is happening. Could you speak?
Video sound is false.
When you're sharing your presentation, you should
Yes.
click to the sound
Yes.
section. I can hear you now.
Okay. Okay.
I think problem is solved. Okay. You can go on, please.
Okay. Welcome to the presentation of our study titled Renewable Energy Applications on Yedikır Dam. This study was carried out with my supervisor, Associate Professor Meryem Evecen. I thank her very much. Our presentation consists of 5 parts, 5 titles: introduction, study area, methodology, designed floating PV system, and results. In this study, as an example of floating photovoltaic power generation plant, a solar facility with an installed power of 1 megawatt peak and a fixed mounting structure was designed at the Yedikır Dam, which has a surface area of 5.93 square kilometers, was determined as the installation location for the feasibility of the photovoltaic plant. Technical design and analysis was performed using PV soil simulation software, and the efficiency of the plant was investigated. The demand for energy is rising day by day everywhere in the world. This rise leads inevitably to greater consumption of fossil fuels, causing greenhouse gases that harm public health and spread throughout the atmosphere. In recent decades, scientists have focused on generating electrical energy from renewable sources to reduce greenhouse gas emissions. They conclude that solar energy is the most convenient source, and they propose using photovoltaic cells for the conversion process. Solar power plants that consist of PV cells need large installation areas to receive direct solar radiation. These regions are generally marginal agricultural lands, building surface and roofs and water areas. In solar power plants installations on marginal agricultural lands, other environmental problems, encroachment on forests, natural habitats, visible pollution, floating photovoltaic modules on water surfaces such as oceans, lakes, reservoirs, irrigation ponds, dams, canals, etc., can be installed. Also, research focusing on the performance of floating photovoltaic power plants showed that they were approximately 1.5 to 22% more efficient than ground-mounted photovoltaic systems, thanks to temperature lowering effect of evaporation. That is, the maximum output power produced by the photovoltaic panel at a certain cell temperature is calculated with the following formula, where PMSTC is the panel maximum power at standard test conditions. Mu P is temperature dependence coefficient of panel power. TC is cell temperature of the PV panel. When the cell temperature is 25 centigrade degree, the installed power of the facility is 1 megawatt, and the annual energy produced is approximately 1.2 gigawatt hours. However, when the cell temperature is 40 centigrade degree, the installed power is 943 kilowatt peak, and the annual energy produced is 1.13 gigawatt. And therefore, there is an annual energy loss of 70 megawatt, which shows us the importance of cooling. For this purpose, we designed a solar facility with 1 megawatt peak installed power and a fixed mounting structure as an example of a floating type photovoltaic power generation facility. This study was carried out using the PV solar simulation program. In the study, the technical and financial analysis of which was carried out the Yedikır Dam, which is located on the Tersakan stream in the Slova district of Amasya, with a water volume of 63 million cubic meters and a surface area of 5.93 square kilometers, was determined as the application area of the floating type photovoltaic energy facility with an installed power of 1 megawatt, as in figure 1, northeast region of the dam. The facility is at a level that will not harm the natural structure of the lake and the biodiversity it contains. According to the sunshine duration schedule published by the General Directorate of Meteorology, the average daily sunshine duration of the region is approximately 5.6 hours, and the average radiation amount is 4.2 kilowatt hours per square meter. The annual total amount of solar energy received is 1,424 kilowatt hours per square meter. For hardware components, we preferred domestic materials as much as possible. In here, 3,333 photovoltaic panels with 300 watt horizontal positioning in a monocrystalline structure were used in the facility. According to academic studies, the approach distance between the two strings, E1, should be at least twice the height. However, because the facility area is also available, this distance was applied 3 times in order to reduce the shadow effect. In our study, height from the ground of the site spacing north 40 centimeters, array distance D1 1.2 meters. Photovoltaic panels with IP67 protection class 3.5 centimeters thickness, 1.65 meter length, and 1 meter width, 18 kilogram weight, and 60 monocrystalline cells were used as solar panels. In total, the weight of 3,333 solar panels on the floating system is 60 tons. When the post-production test results of photovoltaic panels are examined, a panel produces a maximum current of 9.02 ampere and has a voltage of 33.42 voltage when 1 kilowatt hour of solar radiation is received per square meter at an air temperature of 25 centigrade degree. In figure 4, which presents the change of the maximum power point of the panel at different irradiance values when the temperature is constant at 25 centigrade degree, the obtained power is 300 watt peak when the radiance amount is 1000 watt per square meter, which is the test condition. while the amount of radiation is 200 watt per square meter, which is low light level. It is presented graphically that the power taken from the panel is around 60 watt peak. One of the equipment that directly affects the performance of a photovoltaic power generation facility is solar inverters, which convert the DC current produced in solar panels into AC current, which is a more suitable form for transport and use. In the facility were 33 inverters with 25 kilowatt nominal output power are used in total. The total number of solar panels connected to an inverter is 101, and the total nominal power is 13.3 kilowatt peak. Thus, the maximum DC output power of the inverter presented in table 3, 31.8 kilowatt peak, is not exceeded. The pontoon and its components produced by the domestic industry by using ultraviolet stabilized linear low-density polyethylene, shortly LLDPE, raw material have high tensile strength, impact, and puncture resistance due to their material structure. They don't require maintenance as they don't produce bacteria, don't grow algae, are not affected by sunlight, and are produced in one piece. It is an environmentally friendly product as it can be recycled. The unit edge dimensions of LLDPE pontoons are 50 centimeter by 50 centimeter, and their height is 40 centimeter. The pontoons have a load carrying capacity of 350 kilogram per square meter. In order to cover the water surface of 13,000 square meter, which is the facility area, a total of 29.184 of these pontoons must be used. In this study, firstly, it is aimed to obtain optimum energy production performance in the location conditions of the facility by comparing how the energy production performance is affected in terms of solar panel inclination. Secondly, it is aimed to obtain the optimum energy production performance of the facility under location conditions by comparing how the power generation performance is affected in terms of facility azimuth. Finally, it is aimed to analyze the energy production performance of the facility comparatively by using panels with monocrystalline structure and polycrystalline structure in the photovoltaic power facility with the same power and technical parameters. Purpose 1, performance analysis in terms of solar panel tilt angle for the example of floating photovoltaic plant. As a result of the technical analysis made, it was determined that the losses due to partial shade increased with great differences, especially after the 24-degree slope, and the energy losses due to low light decreased with small differences, as in figure 7. Therefore, the tilt angle at which optimum efficiency is obtained from the solar panels used in the horizontal position according to the location conditions is 24 degrees. To propose 2, performance analysis in terms of azimuth angle for the example of floating photovoltaic plant. As presented in figure 8, it is seen that the energy loss due to partial shade has a significant effect on the plant efficiency. In model, it was determined that the solar panels reached the maximum energy production capacity when the inclination angle was 24 degrees and the azimuth angle was 184 degrees. Annual generated electrical energy approximately 1.2 gigawatt hours. Propose 3, performance analysis in terms of solar panel crystal structure for the example of floating photovoltaic plant. It has been seen that it is not important whether the solar panels with the same cell and diode number, nominal output power, and produced in the same place are monocrystalline or polycrystalline in terms of energy production. It has been determined that the low light performance of the panels is also the determining factor in the total efficiency of the facility. As a result, it is predicted that the electrical energy produced in the floating type photovoltaic facility will meet 19.3% of the annual total consumption and 80 0.6% of the consumption of only industrial enterprises, according to the electricity consumption statistics of Slova district for 2019. Assuming that the electrical energy produced at the facility appeals only to residential subscribers, it is calculated that 53.1% of the residential subscribers will meet the annual electricity consumption. In addition, according to the greenhouse gas emission analysis, an average of 748.9 tons of carbon dioxide per year is not released to the nature, thus providing clean energy with an efficiency of 93% and contributing to the protection of nature, as in figure 11. Thank you for listening. I wish you healthy days.
Thank you very much, Mr. Abdullah. This is very valuable study. I understand because as I know, the floating type photovoltaics is using in some countries, but I don't know, is there any in Turkey? Do you have the idea?
Absolutely. Yeah, we will, and thanks for your...
You can talk in Turkish, no problem.
Okay. Teşekkür ediyorum katkılarınız için. Şöyle söyleyeyim, yani özellikle biz tarım arazilerini bu konuda değerlendirmek yerine daha çok atıl vaziyette duran, hatta suyun buharlaşmasının da önleyerek aslında ekstra bir fayda sağlayan su yüzeylerini bu konuda değerlendirmemiz daha elverişli ve daha verimli olacağını düşünüyoruz. Yani özellikle enerji altyapısı olarak da hidroelektrik santrallerin bulunduğu barajlar değerlendirildiğinde zaten enerji altyapısının da hazır olması nedeniyle maliyetler de olabildiğince düşmekte. Bu şekilde yüzer tip fotovoltaik tesislerin daha elverişli olduğunu düşünüyoruz.
Thank you very much for your contribution to our Congress. Have a nice day and see you. You can leave. Thank you. Okay, now the last presenter is Emine Yoğurtçu. Okay, 1 minute. Okay, Emine Yoğurtçu is a master's student at Hatay Mustafa Kemal University, Department of Physics. She worked as a health physicist in radiation oncology department and several industrial sector. She will present us entitled Investigation on Cobalt Deposited Activated Carbon Catalyst to determine the hydrolysis characteristics of BN compounds. Okay, Emine, I think I made a mistake because your title is different. I'm sorry. And the title of the speech is Vibrational and Quantum Chemical Investigations on Antimony Complexes by using DFT and SQM.
Yes.
Okay, thank you. You can share your, okay, you are here now and very clear. You can go on, please.
Graduate of Gaziantep University Physics Engineering, and I'm doing my master's degree in physics at Hatay Mustafa Kemal University under the supervision of Associate Professor Berna Çıtıkaş. Today, I will tell you the results I obtained with the density functional theory methods and vibration analysis methods of antimony tree complexes. I would like to explain the geometric, chemical, optical, electronic, and vibrational properties of the complexes with the method I used. You can see the names and abbreviations of antimony 3 complexes in Table 1. The complexes were determined by optimizing the geometric structures. In my studies, the structural parameters, nonlinear optical properties of antimony 3 complexes were calculated by Gaussian line program. And I used B3 LIP LIN to the set, base set, and the method. And here you can see the 3D versions of the complexes, and I obtained these images again using the Gaussian program. Now, I want to talk about homolumo. It is known that in covalently bonded compounds, electrons are found in molecular orbitals formed by atomic orbitals. The orbitals here all have different energies. When the molecular orbital is examined, while some orbitals are full, and it is observed that some orbitals are empty. The highest occupied orbital is called HOMO, and the lowest vacant molecular orbital is called LUMO. In these figures, you can see the homolumo image of the complexes. And LUMO, HOMO, the energy between differences HOMO and LUMO, ionization potential, electron affinity, chemical hardness, electronegativity, chemical potential, softness, electrophilic index values in electrovolt for 3 complexes. The energy between HOMO and LUMO is called energy band gap. The energy band gap is used to predict the stability, resolution, and the color they produce in solutions. The energy band gap is an important parameter for the stability of structures. It may not show the true definition of orbitals, cavities in the boundary region. Therefore, the potential density of state of complexes was calculated using the Gaussian program. And the PDOS image of the complexes as in the figure. I want to say that this red peak indicates the highest concentration of antimolecular, and for 3 complex, this orange peak indicates the highest concentration of ring, and the last one for 3 complex, the red peaks again indicates the highest concentration of antimolecular. Now, the polarizability, the first order hyperpolarizability, and the relative component values of the title components and Rhea were given in the table. Rhea, one of the prototypical molecules used in the study of the NLO properties of molecular systems, and therefore it was used frequently as a threshold value for comparative purpose. Now, I want to talk about MAP. Molecular electrostatic potential is a useful method used to explain reactivity, structure activity, and hydrogen bonds of molecular behavior. The red regions are the negative charge, electrostatic potential regions, and represent the attraction of the electron by the electron density concentration of the molecules. And blue regions are positive charged, electrostatic potential regions are and correspond to proton repulsion by atomic nuclei in region of low electron density and nuclear charge not fully conserved. Map is in 3D form. It allows us to see the changing load zone. Charge distribution information is used to determine charge-dependent properties and interactions of molecules with each other. On the map, the regions where the molecules strongly attract the outer electron is colored blue, has the highest potential energy value, and it is positive. And on the map, the region where the molecule strongly repels the outer electron is colored red, has the lowest potential energy value, and it is negative. In the last part, the scaled quantum mechanical calculations have been performed by using experimental data, normal mode analysis, and their assignments were carried out with SQM total energy. SQM total energy distribution products for dot compounds. I used the SQM and Gauss-Lie program to determine harmonic frequency and mark the names of stats. The methods used in this SQM method are given respectively. Entering the approximate geometry of the molecule to be analyzed as data. Geometric optimization is selected, the basis set to be used selected, then calculated by taking the first analytic derivatives of the energy. The geometry of the molecule with the lowest energy is found. The geometry obtained as a result of geometric optimization is entered as data and the calculation model is adjusted. Then, using the force constants, the vibration frequencies are analyzed by the harmonic approximation method. Analyzed vibration frequencies are scaled using exciting scaling factors to match experimental values. I calculated the theoretical and experimental vibrational frequency of the normal modes and the theoretical infrared intensity of the complexes. I examined in this table and the TET percentages with the marking of the vibrations of the normal modes. And these are the TETs. And third compound. Finally, these are the RMS errors. The RMS errors of the three molecules whose vibrational frequency were calculated are divided into regions and shown in the table. And these are my references. So, thanks, regards.
And thank you very much for your presentation.
You are welcome.
And contribution to our Congress. And do we have any question? I see some name from the physical department. Maybe can be asked some question. Please send me from the chat. Okay, I think we do not have any question. Thank you very much, Emine.
You're welcome.
Good luck in your study. Okay, and now we will finish this session. I would like to thank to all listeners joining to this session. And next session will be start 10:15. See you the next session. Have a nice and healthy days. Bye.
üreten, araştırma yapan, ülkenin geleceğine ışık tutan bir üniversite olmak amacıyla kurulan Atılım Üniversitesi, bu hedefi gerçekleştirmek ve daha ileriye taşımak için kararlı adımlarla ilerliyor. Bu adımlardan biri olarak kurulan Atılım Üniversitesi Hidrojen Enerjisi ve Yakıt Pilleri Araştırma Grubu, enerji sistemleri mühendisliği çatısı altında çalışmalarını yürütmektedir.
Ben Profesör Doktor Yılser Devrim, Atılım Üniversitesi Enerji Sistemleri Mühendisliği bölümünde öğretim üyesi olarak görev yapmaktayım. 2014 senesinden beri lideri olduğum Atılım Üniversitesi Hidrojen Enerjisi ve Yakıt Pilleri Laboratuvarı'nda çalışmalarımızı sürdürmekteyiz. Günümüzde en fazla kullanılan yakıtlar olan hidrokarbon temelli yakıtlar bilindiği gibi çevre kirliliğine ve karbon ayak izine sebep olmaktadır. Bu nedenle temiz ve sürdürülebilir enerji arayışı günümüzde hali hazırdaki enerji kaynaklarının da gelecekte tükenmesi tehlikesiyle karşı karşıya olan dünya için oldukça önemli. Alternatif enerji kaynakları içinde hidrojenin sağladığı pek çok avantaj nedeniyle gelecekte önemli bir yakıt olacağı bilinmektedir. Bu nedenle hem dünyada hem de ülkemizde hidrojen enerjisi ve hidrojen enerjisine dayalı güç üretim teknikleriyle ilgili çalışmalar gün geçtikçe artmaktadır. Biz de bu kapsamda Atılım Üniversitesi Hidrojen Enerjisi ve Yakıt Pilleri Laboratuvarı olarak hidrojen üretim tekniklerinin geliştirilmesi, hidrojen üretimi için fonksiyonel nanoyapıların hazırlanması, özellikle savunma sanayi uygulaması için yakıt pili sistemlerinin geliştirilmesi ve bu sistemlerde kullanılacak olan bileşenlerin yerli olarak hazırlanması ile ilgili çalışmalarımızı sürdürmekteyiz.
Ülkemizin gelecekteki güçlü ekonomisi, yüksek yaşam kalitesi ve ulusal güvenliği için enerji alanında sürdürülecek bilimsel çalışmalar ve bu çalışmaların çıktılarının ticarileşmesi son derece önem taşımaktadır. Araştırma grubumuz geniş laboratuvar altyapısı ile hidrojen enerjisi ve yakıt pilleri alanında bilim ve teknolojinin gelişmesini sağlayarak bu teknolojilerin yerli olarak geliştirilmesine katkıda bulunmayı kendisine görev edinmiştir. Araştırma grubumuzun hidrojen enerjisi ve yakıt pilleri alanında gerçekleştirdiği çalışmalar öncelikle TÜBİTAK, Avrupa Birliği ve Üniversite Sanayi İşbirliği çerçevesinde ülkemizde önde gelen savunma sanayi firmaları ile yürütülmektedir. Hidrojen teknolojileri ve yakıt pilleri sağladıkları stratejik önem sebebiyle savunma sanayi ve uzay uygulamalarında ihracat lisansı gerektirmekte ve ticari satışları teknolojiye sahip ülkelerce engellenmektedir. Bu nedenle bu teknolojilerin ulusal olarak geliştirilmesi son derece önemlidir. Araştırma grubumuzda yürütmekte olduğumuz çalışmalar son yıllarda ivmelenerek büyümekte olan milli savunma sanayi hamlemize ve açıklanan Milli Uzay Programı'na büyük katkı sağlayacaktır. Bu kapsamda ilgili savunma sanayi firmaları ile ortak çalışmalarımız halen devam etmektedir. Araştırma grubumuzda yaptığımız çalışmalar son yıllarda özellikle hem düşük sıcaklık hem de yüksek sıcaklık proton değişim membran yakıt pili bileşenleri üzerinde yoğunlaşmıştır. Hidrojenin yakıt olarak kullanıldığı yakıt pilleri son zamanlarda yenilenebilir enerji alanında adını sıkça duyuran inovatif ve yenilikçi çözümlerin başında gelmektedir. Grubumuzda PEM yakıt pili bileşenlerinin geliştirilmesi, karakterizasyonu, yakıt pili testleri ve yakıt pili sistemlerinin hazırlanması üzerinde nitelikli araştırmalar yapılmaktadır. Yaptığımız araştırmalar neticesinde düşük maliyetli PEM yakıt pili membranları, katalizörleri ve membran elektrot ataçları ticari ürünlere eşdeğer performansla yerli ve milli olarak üretilebilmektedir. Araştırma grubumuz tarafından ülkemizde ilk defa reformat gazlar ile çalışabilen yüksek sıcaklık yakıt hücresi ve bileşenlerinin tasarımı geliştirilmesi ve mikrokojenerasyon uygulaması gerçekleştirilmiştir. TÜBİTAK tarafından desteklenen projemiz kapsamında yüksek sıcaklık PEM yakıt pili teknolojisi tüm bileşenleriyle tamamen yerli imkanlar ile geliştirilmiş ve hazırlanan prototip sistemde mikrokojenerasyon uygulaması yapılmıştır.